Hello to everyone. I'm Professor Jelena Vasiljević from Serbia, University Union. I used to work on another university, Belgrade, and Institute Mihajlo Pupin for 19 years. And I'm here on University Union School of Computing for 9 years. I'm teaching artificial intelligence, neural networks, algorithms, and some subjects about my PhD, multifactorial analysis, applying on medical images. So I'm collaboration with medical doctors, as we used to hear your paper and another. And I used to have invited talks in Sydney, actually. So this is interesting. Before me, I will present like some summary of my work. Application of computer intelligent systems in tumor diagnosis. My PhD and projects after that were about diagnostics, cancer, applying multifactorial analysis, and after that neural networks, especially CNN, convolution filters on medical images. I used to make those pictures actually when I had the chance in clinics. And after that, and especially now after COVID or with no chance. Sorry?
Okay. Slideshow.
Oh, thank you. Yes, yes.
Sorry. Where is it? Which one is it? Sorry.
Sorry. As you can see in this, thank you very much. As you can see, this picture behind that, do you know what picture is that, maybe? Have you seen it? Front of? What is it? This is fractal. This is one picture of nice fractal. Those are pictures according to mathematical equations. Get it? But you can use that softwares actually in application on medical images and other, images. But actually, fractals do have really good applications in chaos theory applications and explaining of chaos in quantum physics. And actually, that is idea after that of application in cancerogenesis. Cancer is not spreading like, chaotically. There is some equations about those spreading and multiplying cells. First of all, I applied a multifactorial analysis. Those are analysis with multi-parameters, more parameters than just fractals. And I applied it in cancer diagnostics, and after that in prediction of efficiency of chemotherapy, and those are results very, very good. State of art is that there is no such objective method in applying which patients will go on chemotherapy. You just check those health parameters of that patient, and with this software you can apply that personal health. You can tell that patient according to this analysis, which are predictions and accuracy of applying specifically that chemotherapy, which is very, very important. These are my colleagues from medical faculty and from Institute of Oncology. My co-mentor is Jelena Vasiljević. I had PhD of Electrical Institute, actually, electrical faculty. So we have collaboration with the clinics and universities. That is about me and my team now. Actually, my team now are my students. This is about me, my subjects, and fuzzy logics used to teach in robotics. nowadays these are subjects divided in applied artificial intelligence. And more of those subjects are from PhD now on primary studies. So our students are, I don't know, more intelligent, and they are very good. As I said, this picture, now you can see better. It's very, very nice. I think it's used to be on, like a background on desktop. It looks like holograms, if you zoom each part, whatever part, if you zoom, you will get the whole picture again. That's the main characteristics of fractals, those self-similarity. And that's why it has applications in explaining of cancer diagnosis. So fractals, we used to apply fractals, only fractal tumors, fractal parameters on tumor markers. Actually, tumor markers are very, very expensive. I didn't know before this research. And on this way, we got really good results, even better than tumor markers. But with multifractals are much better for images of I used to work on microscopic images first. You took biopsies from tissue and then look for actually primary tumors. For example, I have some examples after. You will see, but it's really interesting that doctors take example of tissue from bone actually, and it's metastasis in bone, and they are searching for so-called primary tumor, which can be in this research. I got like that 3 groups from renal, that's kidney, kind of cell in kidney, from breast or from lung. It's really fantastic. They can distinguish between total different tissues. They take from bones and they search for totally another tissues. So it was amazing. And before this research, I didn't know that even you can do something with the metastasis, because my father died long time ago, 31 years ago, and that's why I'm doing this. I didn't know that with metastasis you can find a primary tumor where it started, and on that place you can apply some therapy. Afterwards, there is great chance, if you put that therapy on the time. There are unfortunately many patients, they are writing to me, they send me pictures of biopsies, but I cannot help them. They must get through system, or but it's really sad that there are so many patients with metastasis and they cannot find them primary tumors. That's why this applications and the research is really, really important. So why multifractal analysis? It's really fantastic that there is no filtering, there is no furlough of filtering, and there is no way of analyzing. There is no such great loss, like in other analysis of images. Those are advantages why fractal and multifractal image analysis, and there is no furlough of degradation of original image. That's really important, especially in medical images, because, for example, in these microscopic images, this is they took from tissue from some organ, and they put those examples on those, we say for histopathologic, some examples. So there is a lot of chemical and other analysis before taking a picture, if they even take a picture, because there is no regular way of digitalizing that. Even in Australia and in China and wherever I was, there is no some digital base about of those pictures. I thought it's only in my country, but they were really surprised, and I was surprised that even in Australia and other countries, and even on those conferences, I never heard that those digital bases are open, you know, if they even take pictures of those examples from biopsies. There are some theory why, maybe like doctors on that way, you know, protect those, their diagnosis. But COVID made that, you know, better in that way, that there are a lot of now open bases, and we are working from that. Otherwise, before that, I used to go on clinics, you know, for I don't know, years to take pictures. Okay, these are advantages more, why fractals in cancer research. And goals of this research was to distinguish between those three primary tumors, as I said, in lung, breast, and renal. Renal is special cells in kidney. And we used to work with Fractlac from Australia, from university in Australia, and one professor, Audrey Kerperan, she helped a lot. And for statistical analysis, data registration we used in this research. And before that, SPSS, but I found this one better. These are 6 parameters for multifactorial analysis in Fractlac. There are another software very famous from Paris, Institute of Unria in Paris, Fractlab, but this one I find better for bigger data files. You can put big data file at once and analyze it. With Fractlab from Unria in Paris, you must analyze picture by picture, one by one, and I find it much slower. So hypotheses were general to distinguish, you know, to have correlation between those multifactorial parameters and those 3 primary tumors. That was my starting hypothesis. And there were 1,050 tissue images, as I said, from bone, actually, really interesting, and for 3 groups. So I knew before, you know, test data, I knew these 3 groups, and I pictured it, but pathologist, my commenter, checked, of course. So this is interesting that this is how it looks through microscope. For metastatic carcinoma of renal cells, you will see it's really similar with the other 2. For metastatic breast carcinoma and for lung. You see, it's really amazing to distinguish, to find some differences between. So it's really hard for pathologists and doctors to distinguish. Actually, I always ask medical doctors, where do they need some, you know, applying of this software, or nowadays CNN, neural networks, because I don't have to, you know, discover something old. But differences between applying in clinics, this kind of multifactorial analysis and neural networks is great, is big actually, because we apply this in clinics. Actually, there are some problems because not so much they are using, but we cannot apply actually neural networks because we need data set for testing and for validation after that. But with this kind of analysis, you can apply in clinics right away after, of course, good results in statistical mean. So research results were, first of all, Fractlac put in binary form those pictures, and then results statistical. These are accuracy, sensitivity. Those are metrics for statistical. And because there were three groups, you know, default metric default accuracy is about 33%. That's why this is really good, especially because there is no such, objective and software metrics for that. For breast carcinoma, it was 73 accuracy. These are other metrics. And for renal cells, and you will see after I have results for predictions of chemotherapy, there is accuracy of above 91%, which is really, really good, especially because there are 3 groups. It's usually, even if over 50%, it will be great. So some recommendation about these projects for future is exploration on other organs, on another to improve in the sense of speed, reliability. It means, especially we are waiting before COVID, for pictures of brain tumor, and I suggested to make to put in those neural networks, CNN, actually all 5 types of brain tumors. There are some 5 types because they have doubts for 3 types, and I recommended to put better all types in order not to, make mistakes at first neural networks. In some ideal or not so ideal, in many cases, neural networks can learn, to distinguish and from some new types, but why to wait, better to put all possible types, and after that neural networks can improve and be better than some experts, which are some fears, unfortunately, from medical doctors, that they will be, they won't have to work anymore, but it's not true. This software and other some objective metrics will only help and them and to patients. For predictions chemotherapy, there were some kind of other team and other medical doctors and from Oncology Institute. So in this way, I just got, finished pictures of, in this case, were breast cancer. And we also had 3 groups for data testing sets. We were comparing the results of multifactor analysis with tumor markers, as I said, and it came up, it was much more faster, more accuracy for fractal parameters. It's really interesting, and some future, at least my some wishes to make those databases of microscopic images, which I haven't found until now, unfortunately. So there were actually 3 groups after getting those biopsies from breast cancer, confirming invasive carcinoma before commencing the treatment. They made those pictures, and there were those 3 groups of partial pathological response, complete and progressive stable disease. And results were, as I said, really good. Accuracy were 91.4%, which is very, very good. According that state of art is, there is no such objective metrics for that. They just, tell you need to get that chemotherapy. On this way, they can tell, especially, to that patient with which accuracy they will, get through that special therapy. And of course, for further researches, it should be applied on another. There are, I don't know, several types of chemotherapy. There are new therapies, and it would be great to make this research for each of therapy. And then on that way, you can tell that patient for each therapy how it would be. And some future is to apply that on combinations which you can, for example, by nanobots, nanotechnology, put through body directly to cancer cells, not to invasive health cells, which is great. We had a collaboration with the Houston Hospital, where they have experimental, and they cured on that way a terminal state of pancreas cancer, which is really great, high mortality. So it's really great results, but there is no approval from FDA still, and it won't be soon. So that professor came in Serbia, and we tried to collaborate to apply in Serbia and Europe. In that way, we will avoid immunity degradation with chemotherapy, with radiation, which I also worked in Sydney Image Institute with targeting radiation, not to invade other organs. They had like magnetic resonance in the same device with the radiation device, and on that way, in real time, they make pictures and they put radiation. On that way, it's much more precise, and not to invade and radiate other organs or tissues which are health, which are great contradictions of and chemotherapy and the radiations. These are really therapies for cancer, but they have great side effects. So okay, also for future, we should apply those for other therapies, as I said, and comparing results of multifractal analysis with tumor markers in order to find a better and faster and cheaper solution. As I said, maybe in those nanotechnologies solutions, and making databases and microscopic and other images, because we had research, we had projects, and now we work only with the radiological pictures from magnetic resonance or scanner, even from ultrasound we made. And I made some medical research platform with my colleagues and my students, in which we present to clinics in Serbia some kind of collaboration that we will get all data in mean of images in real time. When they make some pictures, any kind of, we will get that for our applying for analysis, and we are making all other analysis machine learning algorithms for them. That is idea, and COVID stopped us. So, but this is idea for whole world to be on internet. Some kind of gathering on one place, all doctors and experts in artificial intelligence, and we should collaborate and find some better solutions and methods. Because we need much more images to increase those accuracy of neural networks and multifractal analysis. So some functionalities of that platform would be database on one place, and offering data analysis any kind, and actually education part of the platform is really great, because I used that in my faculty, which is for computing, but also it could be used on medical clinics and medical university. And on that way, we can share that knowledge between doctors. You can ask for second opinion. Everybody likes to hear second opinion, especially for such risk illnesses. So on that way, even doctors can ask another doctor, anonymously. So there are great some functionalities. Database will be collecting all kind of data, but especially concerning data privacy. I don't know any name of thousands of those patients. I just know some, unique numbers. Actually, I don't know that, but I just saw that. So on that way, we will have in database MRI images and other medical images. These days, we are waiting for ultrasound images actually from liver. On that way, they can predict if there is some, deformality on liver, preventing taking invasive biopsies, from liver. As I heard, it can be with the errors, and they repeat those biopsies, taking biopsies, which is really painful, and for adults, and especially for children. We used to work for children clinics with children who had, fortunately, bone metastasis or tumors. So it's really great sense of doing this. There is great goals for applying this actually. On this way, we can follow in time those patients and their conditions in order to improve those methods. If you have on one place all those data, you can help them and doctors more. And on that platform, we can apply statistical analysis, machine learning algorithms, and another which everyone could reach from, which can have access on that platform. It would be open, because for neural networks, it's a better way to have more and more data. If there is more data, those neural networks will be more accurate. Okay, for education part, as I said, they can, and patients and doctors can search through all those data images in base and then compare in order to prevent waiting for such a case. You can hear that in another country there were some case of that, and you can just search on that database and you can apply some analysis, or you can apply those statistical results. If you find in that database, I don't know, some rare kind of cancer, you can see which are results for applying special some therapy. That's my vision of future, not to wait, for that kind of patient to happen in your country. Okay, and medical professors could easily find on that way specific image, not only MRI, and make those comparing with their one, and on that way improve in their lectures and researches and applying better therapy. Okay, as I said, and doctors and patients can on that way ask for a second or third opinion and more with data privacy. It's really important, as I heard, and doctors, of course, need, with somebody to check those opinions. We have nowadays a cooperation with the Institute for Neurology, president of Serbian Academy of Science, Professor Vladimir Kostić, because my idea is to apply and multifractal and fractal and CNN and other kind of neural networks and machine learnings on another medical issues, not only cancer, because actually in Sydney, in Australia, I had some kind of collaboration with doctors, Institute for Eye, I think it was, but they were actually doing on multiple sclerosis, and I didn't know that there is no explanation how it is spread. Actually, if you know, multiple sclerosis is vanishing of those on neural cells, those how do you say, those part of neural cells, like you are looking in a mirror, those carcinogenesis, and making disease like multiple sclerosis. You know, it's like opposite, but I think it could be explained actually also with some kind of fractals or multifractals, you know, just vanishing, not multiplicating like in cancer is. So that's why we have idea to apply on other diseases, neurological, Parkinson, Alzheimer, because I don't know if you know, for Alzheimer, there is no 100% method for diagnostic, only, you know, unfortunately, autopsy. So these days they make MRI of brain, and if they don't see, they you know, send that patient home, and unfortunately with some maybe psychiatric diagnosis, which is big mistake, because medicines for psychiatric illnesses and for Alzheimer, dementia, and similar are very contradictory. They can die actually. They can be in coma if they take for, you know, calming and some psychiatric medicines, and it came up after that actually they have some kind of Alzheimer or dementia, which is really the same, and the medications are same. You know, there is no cure for Alzheimer and dementia, but you can slow that process with right medicines. So this, I hope it will help in that way if we have enough images, so MRI of brain for neurological, that on this way we can distinguish those on there is a white and the gray matter on brain. On this way you can find that some special contrast between that, and you can find, actually fractals find that some correlation between Alzheimer and those parameters. As I heard in I don't know, in China, it was before COVID 2017, I was invited in final of innovations, and there were some brain institute. They discovered that there is no one particular center example for speaking. There is multiple centers on and left and right, you know, half of brain. You know, that's why there are explanations for many healings. You know, if somebody is injured and they think brain is injured on that place, they can walk after. But I wanted to say that this kind of research can help in diagnostics and on time, you know, making therapies on time, which is very important. And for neurological diseases and other, I think. This is another fractal that I like, and this is the most. Okay, there is more researches, but I presented here. This. Thank you for your attention. You have questions?